Alright, so simplifying rational exponents. These are the notes for day 2, unit 6, okay? This is a negative 1.5, yeah, so it's 25 times b to the 6th to the power of negative 1.5. Here we go. We're looking at the exponents for sure. We learned rules last class of how we're going to be adding and multiplying or whatever those exponents. And these rational exponents are talking about just fractions. Ratio is a fraction. Okay, so fractional exponents, if you will. Now, parentheses are huge. So PEMDAS, we know, are parentheses, exponents, multiplication, division, addition, and subtraction. These two right here tend to be what confuse people in what we're about to do. Okay? Let me get you into that first. A good way to remember what to do is negative powers. We have a lot of negative in the world. Unfortunately, we're trying to get rid of negative. Okay? So whatever you see that is negative, make it positive. So if I see x to the negative 1, I know that it's over an understood 1. I know that that 1 exists there and on the numerator. There's a 1 that exists right here, guys. It's just not written. It's understood. Okay? So here's the thing. We have to determine what is attached to this negative. What base is attached to that negative 1 power? Okay? Now look. Is this the same as that? It is, right? So it's power of the parentheses. You have to figure out where do these parentheses lie the way that it is written. Okay, those are two the same. Is this the same as if I were to do it like this? It's still the same. You understand? So had I written 25x to the negative 1, you tell me, what's attached to the negative 1 the way you see it right now? Just x, right? Only x is attached to the negative 1. The 25 is not attached to the negative 1. If it was, it would look something like that. You with me? Write it down in your notes because you might forget that. So whatever is attached is the thing that is very, very close to it, basically touching it, and it would be interpreted as 25 times x to the negative 1 like this. So that the negative makes the x move, but it doesn't make the 25 move. We're going to move the base, home base if you will. Okay? So, with that being said, let's do this problem and then we'll go to lunch. And those were some of my student aides, by the way, that just came in. They just graded the homework you just turned in. Alright, so let's look at negative 1.5 as the power. Okay? You've heard me all year say, please stay away from decimals as much as you can. Here's a big reason why right now. Negative 1.5, I want to make it into a fraction. What's a fraction for negative 1.5? Negative 3 halves. Here we go. So this is raised to the power of negative 3 halves. Now, this parentheses, guys, there's so many different things that you could do from here. It depends on you and what order do you like to work things in. Some people like to work with the negative powers first. Some people like to do parentheses. So like I said, the negatives or parentheses, or they'll work fractions inside the parentheses. To me, I like to distribute. If I can simplify in parentheses, If I can simplify in parentheses, I will do that first because of the way that I've been trained basically with PEMDAS. Okay? And then I will work with the exponent by distributing the exponent afterwards. You with me? Okay? To me, there's nothing to simplify in the inside. There's no fraction that I can reduce. So I can go straight to applying this negative 3 halves to two different bases. One is a 25, and the other one is b to the 6th. Why can I do this, guys? Why is this allowed? Because it's multiplied and it's only one term. One term in the monomial, that's when you can, it feels like you're distributing, guys, but you're not distributing. You're applying the power to all the little pieces that are glued together with multiplication. Okay? And that multiplication is important because otherwise you can't do what we just did. Okay? This one's easy. Power raised to a power we multiply, right? So 6 is going to be multiplied with this. I hope you see it like this because it will not be with a calculator. And I hope that you always try to reduce as early as possible. And then after that, go ahead and multiply straight across to see what you're left with. What do I have left with would that be? Negative 9. Here we go. If I wrote b to the negative 9, again, we're trying to take this negative out of the world. I'm going to actually write it as b to the positive 9, but where? In the denominator. Okay? Because, guys, over here, this is over 1. We don't want negative in the world. So we're going to move this down to the denominator and make it a positive 9. Okay? Here we go. 25 to the negative 3 halves. I can move this to the denominator as 25 to the positive 3 halves. An understood 1 is left in the numerator, and we're almost done simplifying. In case you forgot, the root is on the outside and the power is on the inside. Let me highlight that for you real quick. The root is on the outside, which we wouldn't write a 2. We would just interpret a square root. Now you tell me. This 2 out here, you're used to seeing it like this with nothing there. Because there's an understood 2 when nothing is written. Guys, what's easier to do? Take 25, cube it, and then square root that big old huge number? Or is it easier to do the root first?
So you're just splitting the fraction.
Yep. And then cube whatever I got. This one's a lot easier, right? What's the square root of 25? 5. Cubed? 125. So this on the bottom is actually 125 b to the 9. That would be your reduced answer. Go ahead and go to